Hello, everyone. Hmm. All right. Today we are going to be going over structy.net. Honestly, I believe that, I think that I should start off with structy.net rather than neat code or LeetCode. I think that the DSA problems are just a little bit more advanced for me, and I need to start somewhere. And I've heard that on Reddit, people have been enjoying using structy versus neat code because I think that there's a much more easier progression when it comes to learning these things versus just being thrown into either neat code or LeetCode. So I'm just going to be starting off with structy and then hopefully finishing the course and then moving on to neat code. And then after finishing that DSA course, then going on to LeetCode. Yeah. Yeah, let's just start. Okay. All right. So max value. No, just write a function max value that takes in a list of numbers as an argument. The function should return the largest number in the list. Solve this without using any built-in list methods. You can assume that the list is not empty. Okay, so we'll just go with this for now. And nums. If I do get lost, then structy is pretty cool. They give you an approach, and then they give you the walkthrough, and then they give you the solution. But they advise just going through this and then working your way up. So if you get stuck, then just go here and then listen to how he would, tackle the problem. And then from that on, just continue coding. And if you can't solve it within 20-30 minutes, then obviously go through the walkthrough and the solution's there. So I'm just gonna continue. All right, so return the largest number in the list. Indentation block. All right. All right. So we have a list of numbers. Oh, why did I even do that? I'm just gonna do it over here first. Let's just copy this. Actually, let's do that. And let's print out the nums. And then let's, so yeah, so 4, 7, 2, 8, 10, 9, and 4, 7, 2, 8, 10, 9. And so now we need to return the largest number in the list. So we need to create a variable. So initialize variable max or largest. And then set largest to 0. Okay, so largest equal to 0. Now iterate through the nums, through nums array using a for loop. So for n in nums, let's print that out just to see what comes out. Yeah, so 4, 7, 4, 7, 4, 7, 2, 8, 9, 10, 9. Cool. All right, so we can iterate through that. Iterate through the check to see, check if n index value is larger than the largest variable. So if n is greater than largest, set largest equal to n. And then let's print largest. Which would be 10. Now we just print largest. All right. Initialize a variable largest, set the largest to 0. Largest is equal to 0. Let's try a different one. Let's comment this out. Okay. Let's try it. Oh. Mm. Mm. God. I'm gonna watch the video.
Hey programmers, Alvin here. Right now, let's go over the high-level approach we can use for this
Oh,
max
can't
value
hear it.
problem. So this problem is going to be a nice warm-up into our data
No.
structures and algorithms, and it should be just some nice review. It will expose a really core pattern that we're going to use time and time again throughout the course. So in this problem, what we're going to do is take
Wait, I
in
need to.
an array
Sorry,
of
I gotta
small
fix my
numbers. What we want to do is
audio.
return the largest number in that array.
Alright, let's go back.
Hey programmers, Alvin here. Right now, let's go over the high-level approach we can use for this max value problem. So this problem is going to be a nice warm-up into our data structures and algorithms, and it should be just some nice review. It will expose a really core pattern that we're going to use time and time again throughout the course. So in this problem, what we're going to do is take in an array of some numbers. What we want to do is return the largest number in that array. So for this particular input, the answer we should return is 9, right? Because 9 is the largest value there. So let's cut to the chase here and talk about the strategy. So what you want to do to solve this one is use some outer variable. Here I'll just label it as max. And you want this max variable to represent the largest value that you've seen so far. And that kind of begs the question, before you start looking at any of the elements of our array, what should you initialize this max value to? My favorite pattern here is to initialize it to some arbitrarily small number like negative infinity. Typically, most of our programming languages would give you some way to represent a negative
Okay.
infinity.
How do you set a variable to negative infinity? To set a variable to negative infinity in most programming languages use the special float. Okay. Oh, let's do it over here first. So negative floats infinity? Is that it? Okay. Let's try it. That didn't do anything. Wait, did I save it? There we go. Okay. Because I was like, I was getting 0. I was getting 0. Okay. Let's try this. All right. So let's just copy this. Nice. All right. So is prime is the next. How much time do we have? Oh yeah, we forgot to do the complexity. Let's go back. Oh, my stomach hurts. Ugh. Excuse me. All right. So complexity, time complexity, and space complexity. All right. So based off of wait, let's go to see if I can swap over to hold on. Mm, okay, that's better. Why did I do that? Let's go over here and then let's switch to studying. So I just turned off my damn computer. All right. So I believe that oh my gosh. So the worst and the best. So I believe that O of n is linear and O of 1 is constant. And log I can't logarithm. Can't even spell that. How do you spell logarithm? Logarithmic. That yeah, see, I already messed up. Logarithmic. Jeez. That is O of log of n. Worst case, best case. And I think that O of n squared is something O of of C and N. And then I think it's O of N. I forgot. But in this case, I just can't see that. We talked about it, so I don't know these cases, but let's go back to the problem. Oh gosh, my stomach hurts. Oh. Time complexity and space complexity. So I'm assuming. Ooh. Since we're iterating through an array. If we're iterating through the array, and if we're checking every index of the array, so if we, in that case, it was like 4, what was it? 4, 7, 2, 8, 10, 9. So if we're trying to set largest to something and negative infinity is there, so we check 4. 4 is obviously it's the largest. It's larger than negative infinity, so it's 4. And then what? Jesus, this is so confusing. 7 is larger than 4, so it becomes 7. Oops. Wait, let's move this. Can y'all even see this? So if n goes like 4 n in nums, if I can spell in nums, for n in nums, and if n is greater than largest, so obviously n, so it's n0, n1, n2, n3, n4, n5. So yeah, so we check 4. 4 is greater than negative infinity. 7 is greater than negative infinity. Sorry, not in oh my god. Stupid. So 4 is greater than negative infinity. 7 is greater than 4. Seven is greater than 2. 8 is greater than 7. 10 is greater than 8. If y'all can see that. And 9 10 is greater than 9. So return largest, which is 10. So I don't know why I spent all that time doing that, but uh, make that smaller. So actually, go over here. So we have to check every time. That can't be. What was it? If it's going through O, if it goes through O of big O of 1 and big O of n, I think it's O of n. Oh my gosh, I'm forgetting my notes. Go back. So O of n is grows based off of the input. Yes. The growth of the algorithm runtime is directly proportionate to the size of the inputs, essentially meaning that as the input n increases, the time taken by the algorithm also increases. Right. So I'm assuming that this is O of n in time complexity. And in space complexity, I think it's also. Is it O of. I don't know. Or I could be wrong. I don't think it's. Let's check. Okay. It says that, yeah, O of n and O of 1. Let me check. Wait, let me go over here. What is space complexity? So as time as this as space goes up, so does time. So it goes like that. And O of 1, no matter like how many input, it takes the same amount. If there was 10 books, it would take the same amount of time. It would take the same amount of time to pick up book 1 versus book 9 because it. Okay. But why is it? Oh, okay. So the time, yes, is O of n, O of n, but the space of it is still, it's still O of big O of 1 because it's constant versus versus. Sorry. It's big O of 1 because it's constant versus linear. Because linear, okay. All right. Just go to is prime. Okay. All right. Oops. Wrong. All right. Write a function. My stomach is killing me. Write a function. Write a function is prime that takes in a number as an argument. The function should return a boolean indicating whether or not. All right. So def is prime and return something. So is prime. Let's do 2. Is prime. 3. Is prime. Let's find something like a different one. 25. Oop. Is prime. 248. Is prime like 1. Actually, just do all of them. Okay, 3. Ooh.
When you shop Albertsons.com or in the app, you'll get the same prices, deals, and rewards as in-store. You can count on our associates to treat every order with care. That means everything on your list is chosen and packed with the same attention to detail.
My stomach is killing me.
Guaranteed fresh or your money back. And you can enjoy pickup or delivery in as soon as 30 minutes. Shop the deals online or in-store today. Restrictions apply. See details at Albertsons.com.
Why am I doing? I could just not do that and just put it in here, but I'm weird. Okay. I went all the way through to do that. My stomach is killing me. I had spicy like fried rice, nasi goreng, and my stomach is all right. Write a function is prime that takes in a number as an argument. The function should return a boolean indicating whether or not the given number is prime. A prime number is a number that is only divisible by two distinct numbers, 1 and itself. For example, 7 is a prime because it is only divisible by 1 and 7. For example, 6 is not a prime because it's divisible by 1, 2, 3, and 6. You can assume that the input number is a positive integer. Okay. So I would say that we should iterate through an array of we should iterate so yeah, so basically if the number is like 4, the number is 4, then we should go like, my gosh, it should be like 4 3 2 1, right? So of iterate through an array of numbers. I forgot the word for that, but like iterate through numbers starting with 1 and ending in n. Sorry, let's just make it iterate from 1 to n. All right. So for I in range, so I think the range method goes like start, step, and stop. So let's start. Let's with start with no, it has to be 1. Start with 1 and then end with n. Return, just not do that right now. If check I for I don't even know if that's right. So if I had, we should figure that out. So how to check if a number is, well, it says it's divisible by 1 and itself. So if it's 4, use the modular, yeah. If it's 4, if it equals, let's, gosh, stomach. 4 modulo of 1. Wouldn't that always be 1? So let's use like 7. Yeah. Yeah. Wait. Should it be 2? What about 3? So if it was 7, it'd be 1. But if it was 3, if it was 4, it'd be 0. Okay, so if uh if n, so n divided by, let's try it. So if I comment all of this out, sorry, I'll comment these out. Nope, I forgot how to do that. Hey, forgot how to do that. Yeah, I think it's I, so let's print I. Ooh, what the fuck? No. Oh, I need to remove these two. Uh, what? All right, let's try again. All right, so it's 1, 2, 3, 4, 5, 6. Yeah. So my gosh, I is this, and n is n. My gosh. Let's try that. So I would be, and then n would be 7. So 7 divided, what's 7? 7, the module of 2 would be 1. What's 7 modulo of 3? 1. So what's 7 modulo of 4? 3. What's 7 modulo of 5? 2. So it has to be, so if it's 7 modulo of 1, then it would be 0. And if it was 7 modulo of 7, then it'd be 0. So, okay. So n module of 1 should equal 0. Alright. This is bothering me. Why is this not going away? Okay. If n is equal to 0, if it equals to 0, then return. Wait. Gosh, so if 7, because I'm not getting this right now. So, sorry, if it was 7, we would want it to be true. Oh no. If it is true, if it is that, then it would return. If it doesn't equal, if n is divisible by that, and if it equals, then it would be true. So that would be false. Okay. That would be false, and then this would be true. Jesus. Return Boolean. All right, let's try it. Oh no, I should. I should store this in something. I don't know. No. No, that's not. Whatever. We'll just run this. Eh? Expected true got false. I. Hey. This is not right. Oh. Okay. How? Okay, I'm stumped. Let's just watch.
Hey programmers, Alvin here. Right now, let's go over the approach we can use for this isPrime problem. So in this problem, what we're going to do is take in a number. What we want to do is return a Boolean, right? Indicating whether or not the given number is a prime. So recall from math, a prime number is a number that's only divisible by 1 and itself. So if my input is 7, I should return true, right? 7 is a prime number. And the reasoning is 7 is only divisible by 1 and 7. Let's take a look at another example. Let's say I gave you a number like 11. 11 is also a prime number, so you should return true, right? 11 is only divisible by 1 and 11. Taking a look at the opposite case, let's say I gave you 8. Here you'll want to return false. 8 is not a prime number because it's divisible by more than just 1 and 8, right? It's also divisible by 2 and 4. And if I can find like any other numbers that divide into 8, then I know that it can't possibly be a prime. All right, so let's come up with a strategy for this one. Let's go back to the scenario where our input is 7. So we know according to the definition of a prime number, it needs to be only divisible by 1 and itself. So to check if a number is truly prime, then we can just, iterate and
Oh no.
then we can just, iterate and check any possible divisors or factors. Of course,
Yeah, we got that.
right? So now I check is 7 divisible by 3. It's not, so I keep going.
Yeah.
Is 7 divisible by 4? It's not, so I keep going. 7 divisible by 5? That's a no. And finally, is 7 divisible by 6? That's also a no. And at this point, I'm done iterating through any possible factors of 7, and I found nothing that can divide into 7. So now I should return true, right? I wasn't able to find any other numbers that divide 7, so by definition, it must be a prime. Let's take a look at the opposite scenario. Let's say I gave you an input like 9. We know that when we scan for potential divisors of 9, I look at all numbers from 2 up to but not including 9. So that means 2 through 8. And I just iterate in order.
Wait. Oh. That is true. That is true. Wait, what? So 8 divisible by 1. Oh my gosh. Let's go back. 8 divisible by 1 is 0. So that is true. But why does it stop? Let's try it like n, and then we stop at 1. Let's try that. Ooh. I don't know if they like that. Okay, let's go back. Why is it stopping? Fuck it, bro.
order. So I start at the initial factor of 2 and I check. Is 9 divisible by 2? That's a no, and that means that 9 is definitely not a prime number, right? A prime number should not be divisible by anything besides 1 in itself. So that'll be our core algorithm. And when it comes to implementing this like divisibility pattern, it's actually really basic. We can just use modulo. I'll save that detail for the full code walkthrough.
Okay, so if in this case, so it stops here. So if it were 7 is divisible by 2, which would be 1, or what is the fuck is that? Is that? Yeah, it's 1. So, and then if this was a module of 2, I think that'd be 0. Oh. Gonna have to wrap this up soon.
What do we know about the time complexity of this one? It's going to be constant O of 1 because we're just using a handful of variables and we're things. In other words, instead of any formal, all of the factors of 64 just up front, divide 64, then that means that our number is not a prime, right? And if I was able to divide 64 by a, that would result in some number b, right? What does that mean logically? That would be the 64, right? That would be my b. In other words, 1 times 64 is times 8 is 64. And this 4 is 64 in constant number. Now our time constant code nicely. All right, programmers, so what I want you to do is try to code up this one on your own. You can just use modulo. I'll save that detail for the core algorithm. And when it comes to implementing this like divisibility pattern, it's actually really basic. We can just use modulo. I'll save that detail for the full code walkthrough.
Right. Okay, I'm gonna go.
Then we can so it would be like the first plausible factor. Well, what I want to do is start iterating at 2, right? I don't want to start iterating at like 1 because of course 1 divides n, right? 1 is going to divide any number, right? What I want to do is go up to but not including the number n itself, right? There's no
Okay, so he went to 2. Does that change anything? Oh my fuck. Wait. Let's try it. Why would okay, so iterate from 2. Because if you start at 1, obviously you're gonna get, if I start at 1, I'm gonna get 0. But if you start at 2, you will get something, right? So if for 7, obviously. Okay. Duh. All right. So let's try this. Oh my gosh. Oh my. Which one didn't pass? Because it can't start. All right. So if n is less than 1, return false. Because we can't even get there. So let's try that. If n is less than 1, we return false. Our iteration starts at 2, so I don't even need to comment. Huh? What? If one. Oh, if one. Let's try that. Okay, see, I was. Bruh. Yeah, it has to be less than or equal to. Is this right? I want to see. Let's just continue. Let's just.
Right? There's no points of checking if n is a divisor of n because of course it is, right? A number is by definition divisible by itself. In Python, the first argument to range is going to be inclusive, and the second argument is going to be exclusive, right? So that just iterates from 2 up to but not including n. Now all I want to do is iterate through these numbers and check if n is divisible by I. So what I want to do here is check if n mod I is equal to 0. So to check for divisibility,
Right.
it's very classic that we use modulo, right? Modulo will give you a remainder of the division, and if the remainder of n divided by I is 0, then that means that it's perfectly divisible, right? So if this condition is true, then that means I just found a factor of n, right? That means that I is a factor of n. So if that's the case, I should return false because a prime number should not have any factors besides a 1 in itself.
And I was
What I
getting
want to do
tripped
is,
up on
after
there.
I'm done checking every possible factor and I found none, then I want to just return true. So it's really important that I put this return true after the for loop. Most common mistake I see students make when they implement this is they have this kind
Right.
of incorrect instinct to write else return true. I know
Right.
that it's invalid to put a return true inside of the for loop because if your for loop has the job of checking for any divisors, then only after you finish checking all divisors should you
Right,
say
because it
return true. You
iterates
can't say
through.
that while you're checking for divisors.
Right.
In a similar way, if I look at this for loop, after the first iteration, you're definitely going to return out of the for loop, right? Because in your if statement, you return. In your else statement, you also return. So
As
both
like
of those things are returning. So then there's no point of having a for loop in the first place. Why are you looping if you're only going to have one iteration? So this is the structure we actually want. And again, at this point, let's go ahead and test this code, and we can talk about it more. We do have an edge case to handle here. So I run these test cases. We're going to fail the very last one. So if I take a look at the
Right, and I did that.
use an explicit if statement that is itself. And so let's go ahead and test this code. See what we get.
Oh. That is. Oh God. If. Obviously, that would make more sense. What am I doing? Crying. No. What?
I hope to pass that last test.
All right, we need to figure out the
So this is a
complexities.
fair solution to is prime. Like we said about the complexity, this will
Oh,
help
no, no.
your runtime, right? Just
It's not. Okay. So time complexity, I would say because we have to this if statement is it's immediate, it's constant. It's not like going yeah. This I think it's also constant because we're just going from, you know, we start from 2, 3, 4, 5, 6. If the n was like 7, there'd be like 2, 3, 4, 5, 6, 7. So 6. So I don't think. But if we are asking, if we're checking every time that we're going in here, it wouldn't be O of 1. It'd be O, big O of n. Because we have to check through this and do this. So my guess is that it's O of n. Time. I'm gonna go for a loop that it might just be O of big O of 1. Okay, let's try.
iterating from 2 up to n, right? So basically O of n iterations. Space complexity is constant, right? Because I'm not using any stored structures, just using a handful of variables here.
Right, he said it's constant, so it's
down on the runtime if you wanted to. You do some math. Technically, you would only have to iterate up to the square root of n. So let's say you wanted to go the extra mile and do that optimization.
no, we're not about to do that. Let's just show me the solution. No, okay, so I think because if he's doing it with the square root, then obviously the time would be square root of n, which we're not doing in this case. So I think it's just n, and I'm not about to do that. Okay, because yeah, we have to import square root inflow from math, and yeah. Okay. That was bruh. Let's move that out of the way. It's been an hour, I believe. Yeah, we're gonna have to call it quits for today. Have prior engagements to attend. Thank you guys for watching, and I will see y'all next time or tomorrow.